My name is Marcos Placona. I'm a developer evangelist for a company called Twilio. Who's not heard about Twilio here? Cool, so quite a few people. Twilio is a communications API that helps developers like yourselves adding SMS messages, voice, video, two-factor authentication, IP messaging, anything to do with communications into your applications. Those are the applications you're already building in the languages you already know. So this is what Twilio is. If you want to know more about Twilio later, just come and find me. I'll be here. I'll be drinking beers with you. So just come and find me. This is as much as I'm going to talk about Twilio right now because I have something that is way more important. And I really want to start by saying I am not a hacker, okay? I will be showing you some of the hacks I've done, and I will be showing you why I've done it and why I was able to do it. But I'm sure that some of you will be way, way better at hacking than I am. However, not being a hacker didn't stop me from being able to hack applications. And this is what I really want you to keep in mind. It's very easy to hack applications if you don't think about security. It's very easy to have your application hacked if you don't think about security. And talking about security, I kind of want to tell you a little bit about myself. As I said, I'm not a hacker. I really do care about security. I think about security quite a lot. I think about how insecure I am at times. So I think about this all the time, okay? And this is not my house, by the way. I have cameras there, but this is not really my house. I just thought I'd get this one out of the way. And I want to show you the next slides as well. So this next slide is really important. So make sure you read the whole of it. And I am only joking. The most important part on this slide is a disclaimer, which I'm about to show you right now, which is this one, okay? I have not really hacked your app. And the reason I have to say that is because companies tend to get suey, and I made up this word, okay? Companies tend to get really suey when you hack their applications and show everyone how you've done it. So I had to be really careful about the things I was doing here, especially because I'm showing everyone this is being recorded. So I need to make sure that I'm not coming on stage and hacking Facebook, for example, because that wouldn't be very nice. But let's just move on. Who here knows how an HTTP request works? Everyone, right? Cool. So the principle of an HTTP request is you've got a user. The user makes an HTTP request to a server. That server then responds. Pretty simple, right? All the logic is on that server. That server responds, and everything is OK. However, there are ways you can get in the middle of it. And funnily enough, when I say you can get in the middle of it, I'm obviously talking about a very famous hack, which is called the man-in-the-middle hack, which is exactly what I just did on the very beginning of this talk. I was showing you what the man-in-the-middle hack is. And what the man-in-the-middle hack is basically you have a new character, which I use the parrot flag to show you this. And instead of making a request to the server, you now make a request to this new character, and this new character then makes a request to the server. As a user, you don't see that. You don't really know what's going on, okay? And this is what the man-in-the-middle does. The man-in-the-middle intercepts every single one of your requests, sends those requests back to the server, and now, oh, sorry, too early. And now, that server returns back to the user. Now, I just spoiled that because my next slide is the greatest example of a man-in-the-middle attack, okay? Who's playing Pokemon? Pokemon Go? No? Yeah, some people playing Pokemon Go? Yeah, a little bit? Okay. Why is Pokemon Go important to this talk? Because Pokemon Go was one of the biggest applications that was attacked by a man-in-the-middle request, okay? The man-in-the-middle hack wasn't so people could get your information, your Google account, your passwords, or how many Pokemons you had. The man-in-the-middle attack was made because they wanted to enable this, right? So the premise of Pokemon Go is You walk around, so you've got the streets, so this is like a Google Map thing. You walk around, and you find Pikachus, you find Bulbasaurs, you find Pokemon. Now, some lazy people decided that, well, I want to catch Pikachus, but I don't want to walk around. So how can I do that? And basically, they found out that every single time you moved on the app would send HTTP requests to a server to say where you were, to show you which Pokemons you could get. So this was like an app. This is an app that is connected to an API all the time, right? So we're not talking about hackers here. We're talking about kids who want to get Pikachus, okay? And why is it important? Because their motivation here is to get Pikachus. So they found a way to go around the system so they could build something like this. Now, all they have to do is they click on the arrows and they can move around and they can get Pikachus. But let me give you, so I just talked about motivation, right? And when I asked how many people play Pokemon here, only some people raised their hands. I bet that a lot more people drink beer here than play Pokemon. So I'm going to tell you the story of Kuba Gretzky. So Kuba Gretzky is a Polish developer who realized that there was a way for him to get free beer. So talk about motivation. Now, before I carry on, I always like to point this out. The Register is a web journal kind of thing, and this is not Kuba Gretzky. This is what the Register thinks is a Polish developer or a Polish hacker. I don't know if anyone is Polish here, but do you dress like this on the weekends when you hack someone? Probably, yeah, of course. Yeah, of course. But let's talk about his hack. So what did Kuba Gretzky actually do? Kuba Gretzky managed to hack an application using loyalty. Okay? Now, he realized that there was a loyalty app in Poland that allowed you to get 1 token every single time you bought a beer. Okay? Every 5 beers you bought, you get a free beer. So stay with me on the motivation here. So 5 beers, 1 free beer, okay? So it's almost like, I know we have a Starbucks on the other side of the road. It's almost like you go to Starbucks to get a coffee, then they give you a star, and for every 15 stars, you get a free coffee. In this case, for every 5 beers, this is Poland we're talking about. Every 5 beers, you get 1 free beer. So loyalty was really, really a big motivation to this guy. He also realized that the way this loyalty application worked was you would go ahead, buy a beer, then someone would scan your phone against one of these beacons here. The beacon would then return a token to the application, and the mobile application would then make a request to the server. Pretty simple, right? So the only reason the beacons were here was so people couldn't just use the app to get free beers. They had to go through this process. What he also realized was if you were to add an HTTP proxy to the middle here, so again, I'm using the word middle, if you were to add a HTTP proxy to the middle, he would be able to intercept every single request the app made, right? And sure enough, he did that. So now he had a token. So this is the authentication token for this app. He also had some information about the beacon, and he also had some information about the products, because as it turned out, it wasn't just beer that you could buy to get free products. He only knew about the beers, and this is what he was interested in. So he had all this information. And if you look at the very top of this thing here, so this is taken from his hack. If you look at the very top, it shows you what server, or it shows you what URL you need to make a request to. It's got pretty much everything you need, right? So, sure enough, he made requests to this server. And every single time he made a request, he got a free beer. Now, one thing about Kuba Gretzky. Right now, it's unknown how many beers he actually had for free. Okay, like he had an unknown amount of beer. All I know about Kuba Gretzky, so this hack happened in August last year, so this was in August 2016. All I know was that Kuba Gretzky hasn't been blogging ever since. He just disappeared. It could be because he's still drinking beer. He's still busy with like all the free beers he had, or something happens. Looking at his blog, and I look at his blog every now and then just to make sure, like he's not, like I want to see if he's back. I want to see what happens to the guy. He used to blog every month, like once a month, like we all do. But yeah, his last blog post was in August 2016, which could be because he got a job, which could be because he got too drunk and he's still drunk right now. But this is Kuba Gretzky's story. Now, what could the app builders, and I'm really talking about this loyalty app, I'm talking about the Pokemon app, what could they have done to stop it? Like, what kind of things they could have done that could actually stop Kuba from doing this, or stop the kids from trying to get extra Pikachus for free? The first thing they could have done is they could have encrypted all the values. Like, as you saw, that JSON packet I showed you had everything in it. Like, you don't have to be a wizard to know how to use those things. It's a JSON packet. Now, if you are a Java developer or if you are an Android developer, I don't know, do we have any Android developers here? Cool. Some Android developers. If you're an Android developer, you will be quite familiar with this. So I'm just showing you how to encrypt a value. And the reason I show this is there's no excuse. Like, it's very easy to encrypt. So this is a Gradle file where you download a library. Then you have your encryption here. So this is how you would encrypt a string. And this is how you would decrypt a string. Okay? Now, the one thing that you need to keep in mind is that when you encrypt a string, you have an encryption key. Okay? That encryption key is right there. And when you do that, obviously, as we've all done in the past, your keys are going to end up in GitHub. So that's just a caveat, okay? And the reason I show this specific page here is because, I think the name of the guy was Luke. The reason I show this specific page here is because Luke made a mistake once. He committed his Amazon AWS keys into GitHub, and by committing his Amazon AWS keys to GitHub, he gave it access to the world, okay? He commits it to a public repository. And he committed this key for 20 minutes. It took him 20 minutes to realize something was wrong, okay? And basically what was wrong was there's people on GitHub who are basically tracking every single push, every single commit to see if a key has been added to GitHub. And whenever a key has been added to GitHub, what they do is they get that key, they spin up a bunch of servers, and when they spin up those servers, they start mining Bitcoins on them. As you do. In 20 minutes, his bill, which is right here, went to $3,000, almost $3,500 in 20 minutes. Okay, so this is the time it took for him to realize that. So the reason I have these slides here is because it's a caveat. Obviously, I tell you, like, encrypt everything. You shouldn't have your keys inside your code. And we're going to talk about ways we can actually move those keys away from your code. The other thing they could have done is they could have used security features, okay, when they exist. So I have to be honest with you. I do not like iBeacons, okay? I do not like them. I think they're crap. And I've given this talk once. And as it turned out, the Estimote people were in the room. And I said that, and they didn't really like it. So the Estimote people are the people who make the iBeacons. So they were in the room. They came and talked to me. But yeah, I do not like iBeacons. If you like them, it's so good. This is like my personal preference. I do not like them. But the one thing about iBeacons is you can actually encrypt them. There's ways you can secure an iBeacon. But as you saw on my previous example, the iBeacons were completely unsecured. Like, there was no security around the iBeacons, so there's things you can do with iBeacons, which is like you can clone an iBeacon, you can do certain things with it. And this is one of the things this specific app could have done. Like, just look at the security features. Like, if you're using external hardware, just think about, what can I do to protect it? Now, the other thing I want to talk about is certificate pinning. And certificate pinning is a funny one because most app developers I speak with, they say, yes, I am making API requests, and I'm making those through SSL. So I'm safe, right? Because I'm making an HTTPS request. Well, no. Because as you saw in my example, on the beginning of this talk, I was also using an HTTPS URL. But you can spoof it, okay? And it's very easy to spoof. So certificate pinning is basically a methodology for you to pin your app into the server. So now you're basically saying, only when you have that same key, only when you have that same public key, you can make a request to the server, okay? And this is why it's called pinning. So it's you saying, right, I've got my app here, I've got my server here, and I can only communicate this way. If someone comes in the middle, they don't have my key. They don't know what my key is, so they can't get any of my information. So certificate pinning, this is one example of certificate pinning, where you basically start with the host name. So the host name is whatever API you're using. Then you move on to actually declaring the certificate key, and then you basically just create the certificate pinner, okay? Now, another caveat on this one is you will notice I have my certificate key here, okay? And we'll get to it in a bit. Now, the other thing I want to talk about is do not trust the device, okay? Because some people say, well, yeah, but when you talk about Android applications, and this also applies to iOS applications. I happen to be an Android developer, but this also applies to iOS applications. The applications are compiled, like they get into the server, they get all messed up, they get all like mangled up and everything, so there's no way someone's going to be able to just open that file. Decompiling an application is very easy, okay? This is not a hacker's website. This is not a hacking tool. This is a tool developers actually use to decompile applications. Some of those developers will use this tool to decompile applications for good because they want to see how they work, they want to try and find a bug. Some developers will use it for the bad. Now, I'm going to show you just how quickly you can decompile an application here. And I'm going to be decompiling the same application I showed you on the very beginning. But basically, decompiling an application is this, okay? So you start off by calling the tool, then you end up with a decompiled application. And as you can see, you've now got all the folders and everything. You've got access to everything in this application. And I'm even going further because I'm trying to get information from this application I just decompiled. So I'm trying to get passwords and everything. And sure enough, I end up just getting those strings, okay? Now, we're just going to very quickly move on to those strings, because I keep on saying, oh yeah, you shouldn't use strings in your application. So what can you do? Like, what kind of things you can do? Because I need magic strings is like what every single developer says. Like, I need to have those magic strings in my application, otherwise I can't communicate. I need to have like the API key or something. So I need to have this in my application. And obviously, when you're talking about a mobile application, because on the server it's quite different, because people won't get access to your keys on a server unless they get access to the server, in which case you have bigger problems. But with a mobile app, as soon as someone downloads your app, they're downloading the entire thing. They've got access to everything. And if they know how to decompile it, then yeah, sure enough, they can get access to it. So a few ways we can protect those strings in a mobile application. One of them is obviously encrypt the key. You can encrypt your encryption key, for example. The second one is one of my favorites, which is just get those keys from a server. So instead of having those keys inside your application, as soon as someone installs the application, as soon as someone opens the application for the first time, get the keys from the server. So that's one way you could do that. One of the other ways I've been experimenting with is getting the keys from the SDK, from the NDK. So the NDK is the native development kit in Android, And the reason I say get those from the NDK is the NDK is all written in C, C++. So it's way more complex than just Java, okay? The code is way harder to decompile than just decompiling Java, okay? So that's one way you could do that. I don't know if you noticed, but I've got links at the bottom of some of my slides. I will be publishing those slides as well, so you don't need to copy the links now, but feel free to take pictures. But I will be publishing those, and all those links will take you to these places. So like this link will take you to this article, which I wrote. Now, things developers, so we talked about things developers can do to stop, but what kind of things can developers do to proactively, what can they start doing? How can they be proactive? Because you shouldn't really wait until someone hacks your application or someone hacks your website until you start doing something about it. One of the things I find that is really useful and not many developers know about is adding tampering detection. And tampering detection is basically a way for you to detect when your application is being tampered with. I was going to use another word. But when your application is being tampered with. So when someone is trying to break into it, someone is trying to do something. And adding tampering detection is fairly easy, okay? Like this is all code you can copy and paste, okay? You can obviously change it however you like, but this is all code you can copy and paste. You will most likely find them on Stack Overflow, and this is how we developers do things, right? We go on Stack Overflow, copy it, and put it in our codes and go live. So this is all code you can get from it. What I'm doing in this case is I am checking that someone actually renamed my app. Because what started doing as well with mobile applications was people were downloading applications, renaming them, and republishing them. And the reason you do that, especially if you use alternative markets, is if the application generates any revenue, now you can start making the revenue out of that application. And that's very easy because you didn't even build the application. So that's one good way, okay? So you can add something like this to your code to check that the application hasn't been renamed. The other thing you can do is you can check that the application has been relocated, okay? When it comes to Android, we can think about the Amazon market and obviously the Play market, but there are so many alternative markets. There are like hundreds of them. Especially in Asia, there's like loads and loads of them because most of the Asian phones, they don't really support the Play Store because they're not like official Google phones. So there are loads of them. And what happens is there's been like an influx of people actually downloading those apps and just republishing them. And then all of a sudden you find out that you've got all of these requests or all of these errors coming from somewhere else in the world that you're not even aware of, because you didn't publish into those markets. So what this code does is it checks like, has the application been installed from the Play Market, the Amazon store? If it has, all good. If it hasn't, then stop it. And this is like, it's up to you. You can give an alert to the user as well to say, hey, you've downloaded this application, but now you're on your own because I'm not going to support this because this is not mine. Or you can just like disable the application. And I was talking to Martin yesterday, and he was telling me he's upset about Pokemon because Pokemon doesn't support rooted phones anymore on Android. And yeah, I know, it's a bummer. But that's, there are reasons for this, which kind of segues into, well, I'm going to talk about signatures now. Checking your application signature is another thing. Every single time you compile an application, a signature is generated. So there's a code that gets generated. And now, with the magic of this Java class, you can actually check your application signature. You can check that the application was actually compiled by you. Okay? If the application was decompiled and compiled by someone else, you obviously don't want other people to be using it, because if you're generating any revenue of this application, now you're probably not anymore, because if they went through the trouble of actually recompiling it, they're probably using their own keys, they're probably using their own like ads account. So this is one way you can actually check. So just check the application signature, and that's good. Now, moving on to the thing Martin doesn't like, which is check if the device is being rooted. So why do I have rooted phones before, and I had the same issues, like I couldn't access my bank at some points because my phone was rooted and my bank was like, hey, we're not having this. The reason you would check if a phone is rooted is because as soon as a phone is rooted, all of the security goes away, okay? You've now got access, you've now got like SU access to this phone. You can do whatever you want to do. So checking if a device is rooted is important because now you can make a decision. And I'm not saying you should always make a decision to block an application when a device is rooted. However, if you're a bank, for example, then you should probably do that. Checking if a device is rooted is fairly easy. What you do is you try to execute a command on that device. And that command is usually SU. So SU is the way you get root access to in Unix systems. So you try and execute SU. And if that succeeds, now you know this phone is rooted, okay? This is one way for you to check that. There are several ways. There are several people. So I think there's an application called Hide My Root, which basically hides the fact that you are rooted. So people try and bypass it. People try and move around it all the time. But there are many ways you can check if a device is rooted. And this is one way, okay? And it works. Check for emulator. 95% of every single application that is hacked are hacked by an emulator. Because it's so much easier. Like, it's so much easier to hack an application that is running on an emulator because you get access to everything than it is to just run the application on a phone and try and hack it via the phone. So checking for an emulator is basically this. Like, you want to check that the application is actually running on a generic. So the Android's emulator is called generic. There are other things as well. There's even one called Goldfish. But there are other things you can check. Obviously, if you want to check for stuff like Genymotion, for example, which is just another Android's emulator, so not the official one. But you can check for those things, okay? And yeah, there's absolutely no reason for an application to run on an emulator. An application you publish, there's absolutely no reason for someone to download it and try to run it in an emulator. So that's the one I would suggest always, like, stopping. If you see people are using your application on the emulator, stop them, okay? There's no reason for them to do that. Rooted phones, maybe. Emulators, no. Checking if the application is debuggable. And this is usually the time when people tell me, well, but hang on. If I compile an application and release it, then obviously my application is not debuggable. So in Android and iOS, whenever you compile an application and you say release, that application moves into release mode. Okay? So all of your comments get stripped out. All of the garbage that you left there gets stripped out. Okay? And this is really cool. So why do I say check if the application is debuggable? Because as it turns out, so this is how you would check. So it's super easy to check. As it turns out, there are ways you can change an application that is in release mode into debug mode. And it's way easier than you probably think. So I've got a little video here which shows you how to make an application debuggable. And so remember, I had that decompiled app. What I'm doing is I'm changing a file, the manifest file, and I'm saying debug equals true. And now the application is debuggable. So I didn't really have to do much. Like, I decompiled an app, which was easy. Like, there was something that did it for me. I got access to the application's manifest, which every single Android application will have a manifest. And I just went ahead and changed one file, and I turned that application into a debuggable application. And obviously, when the application is in debug mode, it's now spitting out a load of like data about the application. There can be logs, there can be anything, and I've got access to it. So this is like a really easy one. Like, check if the application is in debug mode. If it is, don't let it run. And this is usually the point. So we're like, 38 minutes or so. This is usually the point when people tell me, right, so what do I do now? Like, I'm baffled. I'm like, I don't know what to do because you're telling me to do all these things, and I really like, I don't know where to go from here. So one of the things I usually tell people to use, and I was on the high performance talk today, high performance Android talk today, and ProGuards and DexGuard were mentioned, and quite rightly, ProGuards is an amazing tool for you to use, and so is DexGuard. So I'm going to tell you a little bit about ProGuards and DexGuard. As you can see, their logos are very similar because they are from the same company. The things you get from ProGuard, so ProGuard, if you have Android Studio installed, you are using ProGuard already. So that's the good news, unless you have a really old version. But if you have a new version, if you have a new-ish project, you are using ProGuard, okay? And what ProGuard does is, as you can see, well, it's installed by default. Like, if you have Android Studio, it's installed by default. It does name obfuscation, so it actually changes the name of your methods for you when you compile the application, okay? So this is almost like if you come from a web background, this is almost like minifying JavaScript. So it does it for you. It does code optimization as well, which is cool because it does tree shaking, for example, as you mentioned before in your talk, which is like all the garbage you don't need, it will get rid of. Okay, so your APK, like the final compiled version of your code, is going to be way smaller because you're now getting rid of everything you don't need. It will rename things like if you have a variable called banana, for example, it will rename that variable to B or something like that. So it makes like every little helps on this, so it will make your application smaller. And by making it smaller, it will obviously make it less readable. You want your application to be very not readable in this case. Because when someone goes and decompiles it, you don't want them to just look at your code and know about all of your business logic. Then when you look at DexGuard, and DexGuard doesn't come installed by default, okay? And obviously, as you can see, DexGuard does way more. Okay, so DexGuard does stuff like class encryption, for example. When it does class encryption, it does it in a way like it changes some of the characters, so like Chinese characters, for example. So it makes it really unreadable, unless you know Chinese. It does call hiding through reflection as well. So instead of just calling a class directly, you're now calling it through reflection, which makes it harder if you're trying to go through the code flow. It does string encryption for you. It does certificate checks, so it actually checks that the certificate that you're using to access an API is valid. It does debug detection, which I just talked about. It does emulator detection as well. It does root detection, and it does tamper detection. So most of the things I just talked about, DexGuard does for you, out of the box, okay? Now, to the good news and the bad news. Obviously, I just said ProGuard is free. DexGuard costs money. And the way DexGuard, like it's a bit funny the way DexGuard actually charges, because it charges you by the number of users you have in your app. So if you release an application today, for example, it's obviously not going to have that many users, so you pay not much for it. And then next year, if you have 1 million users in your app, you're going to pay way more. So it goes like, I've seen it going from anything between like 4,000 euros to like 18,000 euros. So it varies quite a lot. Okay, and obviously if you have a free application, for example, then having that many users won't be good for you, because obviously you'll be paying way more, even if you don't make any money out of it. There are some other things you can use. Okay, so obviously I mentioned ProGuards and DexGuard. The Safety Net API. So the Safety Net API is an API made by Google. Okay, the good news about the Safety Net API is that it's free, and it checks for things like, is that device rooted, for example? So it does the same root checks. The reason I like using APIs like this, instead of like just rolling my own, is it rooted or not, is, like I mentioned, rooted devices, there are many ways you can actually hide that a device is rooted. And because this is an API, it gets updated a lot more often than your code. So you're basically just sending some information about that device, and Google will automatically, I just made up this word as well, Google will automatically tell you, hey, is that device is rooted, so now you make a decision. And it also tells you if that device is compatible, okay? So this can work both ways, and obviously you can enable and disable those things, because a device that is not approved by Google, like an official Google device, it won't be marked as compatible, okay? Because it's not compatible to the Play Store, so you can't use the Play Store things, and that device will not be marked as compatible. So this one is a two-edged sword because you may or may not want to use that one, depending on the application you are building. Again, if you have a banking application, you probably want to use something like this. Now, implement the network security configuration. So this is one. This is a very new one. So if you're an Android developer, when I say NuGet to you, you probably know what I'm talking about. If you're not, that's okay. So NuGet is the latest version of Android. So it's the very latest version. And the one thing about Android is, as versions go, stuff stays behind. Okay, so if you have NuGet installed on your phone, you can totally use this thing. If you don't, then it's just not going to work for you. And I think NuGet is like a 0.1%. So 4 in every 5 devices are Android devices now. Okay, which is cool. But most of those devices are still using really old versions of Android. If you want to support something like NuGet, for example, it's cool, but you're talking about like 0.1% of the users who are actually going to take any benefits out of it. A guy called Mark Murphy. So Mark Murphy does a lot of security. Like he writes loads of like security blog posts. He talks about security a lot, and yeah, security is very much his thing. And what Mark Murphy did was he made some changes to this API, so it works on Android 4.2, which is currently a version that is, I think, something like 40% of the Android users actually use 4.2 and above. So it just makes this thing a bit more, thank you. So it just makes this thing a bit more flexible for you. So this is one thing as well that you could use. It does a few other things. So it does certificate pinning for you, for example. It does debug overrides for you, so it checks for debugging. So it does a bunch of things. The website actually lists everything it does. It's not the most straightforward thing to integrate with, but again, it's worth like spending some time looking into it. And like I said, with Mark Murphy's version of it, it works from 4.2 and above, which gives you like a bit more room to play with. And I'm going to open for questions in a minute. But I want to finish this by saying the internet is not a safe place. Okay, there's absolutely no safety on the internet. So there's absolutely no safety. It's a very dodgy place. And obviously, mobile devices, they fall into that same category because obviously you are going to be using some internet at some point. So it falls into the same category. But the one thing you need to keep in mind is that when it comes to safety, you need to make sure that you protect yourself. Like, just think about ways you can protect. On this early talk I saw today, this extreme Android performance talk I saw today, the speaker was actually talking about things you can proactively do to actually, try and hack your code, go into how your code runs, and see what it does, and think about ways you can hack it. So every single mobile application I build, I try to hack it as well. Every one of my friends who builds mobile applications, I say, hey, can I have the APK? And I try to hack it. And sometimes they think I'm a douchebag, which is fine. But it saves you, and it saves them a lot of headaches. Like, I'm not trying to slag them off by saying, you've not thought about security, but it saves people a lot of headaches. With that, I was Marcos Placona. My Twitter account is here, my email's here, GitHub, androidsecurity.info is the website I run, and I work for Twilio. If you want to ask me any questions about it, feel free to ask. And obviously, if you want to ask me any questions about this talk, feel free to ask me. Thank you very much. And obviously, I do realize I'm between you and beer right now. So be mindful about the questions you're going to ask, because if it takes too long, then...
Thank you. So all the suggestions you made about being proactive and doing certificate pinning and checking your own signatures of your app, I mean, that all doesn't help if you do not do obfuscation, correct? Because if I can take my APK, decompile it, I mean, I've got access to that code as well,
Correct.
so I just change it.
Yeah.
So there's no benefit, is there?
So the one way you can get around it is if you have your keys, for example, if you have those the things that you check against, if you get them from a server, then you can stop that. If you get them from the NDK, for example, as I mentioned, then you can stop that, or you can mitigate it. Like you can't stop it. Okay, there's like even if you have them on a server, if someone really wants to hack you, they will. Okay.
I mean, more in the sense like I just don't call that method. I got the whole source code. I mean, check for valid signature. I just comment that line out.
Yeah, you're right.
Recompile my APK and I'm done.
Yeah, you're right. You can completely just delete that method and then you're done. So the one way you can kind of go around it is by using codes obfuscation. Okay. And so I know I don't work for DexGuards or ProGuards, but I know it says like ProGuards is the easy way for you to do some codes obfuscation, but obviously people are getting clever about it because ProGuards has been around for a few years right now, and people who really want to hack applications, they know how to get around ProGuards. DexGuards is slightly more tricky, doable as well, but DexGuards, like, I don't think I know how to hack an application that's being DexGuarded. I have hacked applications that have been ProGuarded. And when I say I hacked, I just want to say that again. When I say I hacked applications, I didn't hack to do anything wrong. Usually what I do is when I'm able to hack an application, I get in touch with the developers and I say, hey, so I've been able to do that and I found all this. And that's the end of it. Or if they ask me questions, I just tell them. But I don't do anything wrong with the applications. But you're right. It's if you have access to the code and it's not obfuscated, then every single security measure you've taken just goes out the window.
You said that the best way is to get the key from the server, but before you mentioned as well that if you had a key that you needed in order to decrypt some stuff, then you could just encrypt that one, but then you have to have the key to decrypt the key that you encrypted. You have to get something from a server in order to be safe, right?
You can either get it from the... So the reason I say you can encrypt your encryption key is because it makes it slightly harder, okay? Like, I've seen people going like 18, 19 levels of encryption, okay? So it just makes it slightly harder. And usually what happens with, again, depending on the kind of app you run, usually what happens with hackers who don't really have too much experience about hacking is they just give up. Like, obviously, motivation is a different thing, okay? If you're really motivated to catch more Pikachus, you are going to go and you are going to find out how many times you can decrypt that key until you get to the key. Or, you know, the same with beer. And I think they kind of go hands in hand, Pikachus and beers. But you are going to find this, like, if you are motivated enough. So I say storing keys in the NDK, the reason I keep on going about storing keys on the NDK is many people are scared of the NDK because it's a pain to work with. Okay, like many Android developers I know, many like really experienced Android developers I know, when I tell them about the NDK, they go like, whoa, I don't want to talk about this. So that's one good way, okay? But obviously I published an entire blog post saying that you can do that, and I'm kind of going against myself because I'm telling you how to do it, which means if I tell you how to do it, hackers can read it as well and they can find out how I did it. But it's just that it will stop sort of like low, medium level hackers. Like high level hackers, they'll go past this really, really quickly. Any more questions? Anyone ready for beer? Say yay. Thank you very much.